I believe that we need the automotive segments, like I say, right? Have a special link layer just for automotive. That's fine. You do chiplet, you have to be domain specific. Let me mention two basic things. The chiplet is very hard, but once you define, you cannot change. Software IP can change. Once you're done, especially 5 nanometer, right? Some people say you're too much, sometimes too little, you screw, right? This chiplet cannot be the product. It's a hard IP. So it's hard to define. But once you know this chiplet for automotive, this chiplet for data center, then it's more easy to clear define.
Are you ready for new and unfamiliar challenges around die-to-die connectivity, chiplet integration, and system reliability? Synopsys, backed by its broad experience, close ecosystem collaborations, and comprehensive IP and EDA solution, offers help for fast chiplet-based multi-die system development. Visit synopsys.com/multi-die. Hello, and welcome to the Ojo-Yoshida Report's Dig Deeper series on chiplets. This is Ron Wilson, and today we're talking with Wayne Dai, who's the founder and CEO of VeriSilion. And I think rather than go into further introduction listening to me, Wayne, could you introduce yourself and tell us a little bit about VeriSilion, please?
Yes, I graduate undergraduate computer science, graduate in computer science electrical engineering from UC Berkeley. Then I could become tenured full professor at University of California, Santa Cruz. Early 2000, precisely 2001, I started the company VeriSilion when SMIC China Foundry break the ground. Okay. 19 years after that, 2020, we IPO in NASDAQ-like stock market called Star Market in Shanghai. That's a little bit more, 3 years. So, so by doing two things, one is IP. People are very familiar with the ARM model, so you don't need to build every IP in-house. Another is the service. You don't need to do all the implementation, build a large team to do. So this outsourcing model has been quite successful. The difference between VeriSilion and other normal and service companies, so we have invested last 20 plus years, invest lots in the IP. Of course, in theory, you can say, I don't need build IP, which is the service, but a lot of design right now, we work with system house, you need customized IP. So 40% of revenue is system house, not chip companies. So those times we need the IP, and especially if your own IP, you can customize it, right? So our IP is the worldwide rating, the rating top 10. Even mainly China, Taiwan, actually there's no, only VeriSilion in the top 10. We are number 7 rating. But if you look at the license only, that means excluding the royalty, means not leaving the past business, we're number 5. That means we grow. And the number of category, I'm talking about the digital IP, actually is top 2, close to the ARM. We are top 2. So we have great potential to grow. Okay, that's the IP side. 6 processors, except CPU, GPU, video, or like the AI, or the DSP, camera in, ISP, display out, the display part. So complete. In addition, we have 1,500 mixed signal and IF IP, so quite complete. This is the last 20 years, our R&D expense exceeded 30% of total revenue. We invest heavily for more than 20 years. 30% revenue put into R&D. Okay, so that's how we established that position. I think we are kind of unique, and we have total 1,800 people. 90% is R&D. And among them, about 90% is top, the master degree above from top university, top 10 university from China. So this and the average age is 32. That's particularly is quite different from other places like US. So really we have because we are only assets people, right? So that's really put VeriSilion in a very good position in this particular model.
It sounds like, given your business model and the depth of your IP portfolio and your relationship with SMIC, you are ideally placed to see what's happening with chiplets in China.
We're doing foundry neutral.
Mm-hmm.
Some of the other data service companies maybe mainly do work from foundry because for historical reason. When foundry established, they worry about everyday depreciation. That's if no one comes, then you screw, right? It's not like a IDM, they know what they're doing. So in the 30 years ago, that's true. But now we're established fabric model, so from day one, we think we should not link tied to only one foundry or few foundry. We deal with every foundry. So that's why a few years ago during the shortage, we're doing very well.
Mm-hmm.
Right? Where even the production side is like product increased 30%, while other people even get the allocation of the previous year because we found neutral. I mentioned SMIC because the history, how we established. But from day one, we never locked to one. For example, if we only work with SMIC, you cannot do advanced process, right? So that's where limit you. Yeah.
Could you talk a little about what's happening with chiplets in the China market?
Yeah, chiplet is things. I think I used to be IEEE multi-chip modules. A long time ago, we call multi-chip module IBM, right?
MCM, right?
Yeah, MCM. That time I was teaching Santa Cruz. We have Santa Cruz conference. For 7 consecutive years, there's 4 IEEE society, not one. There's a big society: computer society, package society, device society, circuit system society. Because we think it is a multidiscipline. We need all the society single track. Remember, I'm the general chair, founding chair for 7 years. That time actually, then after a while, I realized when San Francisco conference every year introduced the best new chip integration, we're doing multi-chip. We are kind of second class, right? You cannot integrate one, you put multi-chip or precursor of single chip. Then the name seems like not that good. So the naming is important. So I think about 30 years ago, 90s, I invented the term called system in package. So then I say a system on chip is a special case of system package because the chip, if you cannot package it, the chip doesn't work, right? Sometimes package is more expensive than chip if the chip is so small, right? So that means packaging is important, at least with the one point, so system package. Then I said, particularly I remember I mentioned SIP is not miniaturized PC board, it's a giant chip. That means they have to behave like a chip. Of course, after you open, doesn't matter how many pieces silicon inside, we don't care because you just receive one component, you drop into right that time. So another reason I use the system package because that time we do silicon on silicon when the silicon substrate only do passives, resistors, capacitors, inductors. Why? The capacity occupies lots of area. If you use IC as a waste area, and the resistance, the precision is important. If the line is wider, that means easy to control the precision. And the inductor, the Q, is very important. You need high Q inductors, so in the substrate. Then you put a one chip on top. Then you cannot call this a multi-chip. This is a one chip. But that's different from single chip package, right? So those reasons make I think about system package will be more general. Now, chiplet is nothing more than you have to open multiple pieces. One of the pieces we call chiplet. The concept is not that new, right? Maybe application different. Later we see, right? But I think they just chiplet is one of the component inside system package. Probably that would be more precise defined as chiplet, but now people use the chiplet. Then you talk about so that's why, because of history, I follow the chiplet very well, and we are very aggressive work on chiplet. And I think the one really put chiplet is the one very good at doing giant chip. You cannot say, if people cannot do big chip, you say small chip is good, right? Then AMD, Intel, those are the core competencies of big chip. Why? They are the one leading the wave. Actually, this UCIe, this interface is some from Intel, right? And AMD this time even more aggressive than Intel in a way. That's one of the reasons, right? AMD catch up Intel. That's one of the reasons, because they when 7 nanometer come up, they say, well, I don't need to move everyone to 7 nanometer. Some interface, whatever IP I put into 14 nanometer, continue 14 nanometer. So that move is doing very well. Recently, several Intel product also use chiplet approach. Now, why China particularly interested in that? And besides those reasons, still apply to China, right? Because if chip too big, the yield is low and the line is long. This is not only expensive, but also, right? There's reasons. And another reason, before I to China, I think another one is, for example, right now doing autonomous driving. Right, I talked to the bigger European car company. They say, well, I don't want to do a bigger piece like NVIDIA. I want several chips. My job is a partition, software-defined car, right? Partition, then there's a lot of core competency. Partition into 6 piece, 8 piece. Then I say anyone can come to pick up one piece. You do GPU, you do CPU, you do AI. I hope multiple people pick up one piece, right? Then if so one screw up, I can replace by another one. For example, if one piece of AI is 50 tops, maybe for low-end cars, okay, right now, right? But if you want some other line need a 100 top, next year 100 top put 2 piece, 200 top put 4 piece, for example, right? It's more easy to evolve, to upgrade. And also 2 pieces fail at the same time, chance very low, right? For safety car, right? The naturally fitting safety. You don't want to put in 1 piece, right? The other reasons, I think this is one of the first thing I will see happening is autonomous driving. That like a wave, we're going to help that. Now that's of course China building the electric car, right? That definitely is the one, and I think for China have another reason, because I think in the near term, probably a few years, next few years, probably they cannot have EUV, cannot access to EUV machine, right? Because this export control. So you can, if you say everything need a 5 nanometer, 3 nanometer, that's bigger problem. But if because we know this, not the whole big chip, not every piece need a 7 nanometer, 3 nanometer. Some may be CPUs or GPUs, right? So that way, many of them, maybe 14, 12 is okay, 28 is still applicable. So chiplet also give this mix. You don't need every piece of the chip, right? So that way, only maybe the CPU is the, right? Now Intel talking about make 386 chiplet available, right? Now some US company doing the RISC-V chiplet, right? And ARM, of course, thinking about make ARM chiplet, for example. Now they can use advanced node because they just sell the chiplet rather than China, some company manufacture. China company still can design manufacturing chiplet, right? But with some certain limitations. So that way make this one is more flexible, right? If not everything, whole thing needs to go to advanced node, right? For China particularly, don't have this manufacturing infrastructure. They even have more constraints. That's also, I think, is very good for US companies, right? If they cannot sell the whole chip, they maybe can sell some piece which will really satisfy export controls, CPUs, right? Or something, some pieces.
Do you think that you mentioned that the big industry leaders in North America these days have a history of building bigger and bigger dies?
Yeah.
Do you think that the history of the Chinese semiconductor industry and their quick interest in chiplets may make them more agile in the future and able to produce more innovative products or a greater variety of products than the old line companies?
You mean the China company?
Yes.
Yeah, China company actually reduce cost, not just try to export control problem. Probably actually the main number one reason should be the cost control because chiplet actually can reuse, right? Some of things in the license very expensive, do the risk, other things from cost reasons, more reuse. You can reuse the IP, but you need really a chip, you need to tape out. In this case, you don't need 2 years to tape out chip, maybe 6 months you put the pieces together like a Lego, right? So I think a cost reason probably is another one. For China, mainly consumer can do mostly China, right? Consumers big cost pressure. I think this is one of the big reason for cost reason for consumer market. The reuse. So that point probably is good for the whole world, but China particularly sensitive to that cost.
Mm-hmm.
Yeah, yeah,
But you mentioned reuse, and earlier you mentioned the UCIe
yeah.
interconnect standard. Is China going to develop their own chiplet interconnect standard, or do you see Chinese companies using UCIe or a mixture?
Yeah, so we are probably one of the first company to join UCIe, right? We're very active participating in UCIe. I always believe, the VeriSilion also believe we should have international standards, right? So standard is standard. The way they use UCIe sounds like PCIe, try to remind people in computing industry without PCIe, we cannot imagine how we can do it, right? So that's will be great potential. Even though there some pieces not that mature, whatever, but the direction is absolutely right. Now, you remember China standard. The UCIe is March of 2020, right? This is also the big giant, right? This is Intel, AMD, Qualcomm, Samsung, TSMC, SE, Google, Meta, Microsoft, right? For the whole industry joined. This is very specially, right? This is Intel and AMD, right? They do your own ways, agree, right? And unfortunately, there's no IBM. I hope IBM there, but AMD and Intel, they all agree on one standard. That's significant. And of course, including Google, Microsoft, Meta, right? So that this even though I think some part need to be mature, but they only define the physical layer. It's not a link layer not yet to be defined. So you still can. There's lots of flexibility, but there's no reason in the physical layer you need to do something just for sake of different, right? So my position is yes, this reason later I mentioned there's a couple standards in China doing this. But I think overall we should at least compatible with international standard. December 2020, late that same year. Okay. So there's one activity, right? That in China, this is the first China native chiplet interface. Right. So this official passed the review of China Electronic Standardization Association. This is a government kind of standard community under China Ministry of Industry and Information Technology. So that's the one manage the whole industry. That's the official one. Right. I think the reason they include, but this one actually is a compatible PCI in the way the physical layer compatible. So that's correct thing to do. You cannot say Intel have a CPU chiplet and you say, well, you have to support China standard, otherwise I cannot use it. That would be a very stupid thing to do, right? Physically, you cannot say I will ping something different. That's not. But some of the layers, they have some particular ones. I think that's okay. I believe that we need the automotive segments, like I say, right? Have a special link layer just for automotive. That's fine. You do chiplet, you have to be domain specific. Let me mention two basic things. The chiplet is very hard, but once you define, you cannot change. Software IP you can change. Once you're done, specify nanometer, right? Some people say you're too much, sometimes too little, you screw, right? This chiplet cannot be the product. It's a hard IP. So it's hard to define. But once you know this chiplet for automotive, this chip for data center, then it's more easy to clear define, right? So I think that has back to I think we need, I mentioned to Intel, mentioned to other people also, we should, for automotive, we should have link layer on top. Just optimize for for automotive, but automotive is one of the three area will be landed first for chiplet. Okay, so I think it's okay as long as physical layer is compatible. Okay, so that can't say China standard, but is still in many ways compatible. Okay, I think the reason they have this the motivation is international chiplet usually for advanced package, right? The 2.5D and other things. That this whole reason, right? But domestic is not that advanced, right? The chip is not, so they call domestic conventional package. That's the problem, is not the motivation of the chiplet or for outside China. So therefore, that's the real reason for this standard board in China to support both, but including conventional, domestic conventional package. But they make the physically compatible. That's not bad, right? It's not like I make different, but I want to take care of the China situation. Right, still compatible with it, but China want to advance package still fine, but also some want to conventional packaging for cost reason to chiplet is still okay. Okay, I think that's not too bad. It's not try to make a different standard, right? So this is one of the standards. Yeah.
It sounds like there's a good argument that you're making
Yeah.
for the interconnect standards at the link layer and maybe above to become
Yeah.
application specific.
Yes,
Is that what you see happening?
Yes, I think you have to do that because there's no way you think about one chiplet, one thing fits all. Then it'd be very big overhead for others, not fit each one well. Because you, but for once it's domain specific, then you can think about, right, for this domain. I think this is good enough. And the chiplet, one thing is you don't need one guy's tape out. Maybe this chiplet needs 5 nanometer. You can have a join it, right? Everyone have a share cost sharing, right? The ones cost sharing cover the NIE, then later reuse, right? You don't need everyone tape out 5 nanometer for that. So that I think this is good. Now this is whole in the position like a service company, right? We're the neutral party, right? We can say, well, we need to disarm, right? See, you have 5 company, everyone pay 20%, right? Let's do this one. Then, of course, ARM had to agree when they tell ARM that this is not reduce 5 license to 1 license, right? So now I'm saying, well, I'd rather license 5 times, right? Not license once, but they have some mechanism to do that. I say it's not because otherwise you have 5 licenses. You're too expensive. The result is none of the 5 were licensed to your advanced ones. Maybe use less advanced, cheaper ones. You see, later on this should depend on loyalty rather than say, oh, I need the NI. So end up with 5 company do advanced ARM later on license will be quite significant. Yeah. So I think that's I'm finally realized this not reduce their revenue, but potentially increase their revenues, right? So this is a good position, VeriSilion to do something like this, the win-win situation. Yeah, reduce the barrier to use advanced, for example, the IP. Yeah,
you've raised another really interesting question there. I think you mentioned that an important part of your business in the IP world is customization. And from what I've seen, that's true across the IP spectrum.
Yeah, yeah.
But it's a lot harder to customize a chiplet than it is to customize a piece of IP.
Yes, chiplet.
How do you deal with that?
But yeah, chiplet it should be generally used. If you use once, is not ASIC. Chiplet is a general product. Yes, it's difficult. Only at first things you need domain specific. If 5 people willing to pay one chiplet, that means at least 5 people going to use it, right? So now, of course, if they pay upfront, it's not other people for free, but other people need to contribute later on. They are the first one to define the chiplet, and they contribute. So other people come in, they have to pay premium also then. Have later use. So have to take the definition defined by the 5 guys. Yeah. So have to be domain specific. You have to be real customer. Otherwise, if we're the IP guy, the one that provide chiplet, first they have IP. Chiplet is a kind of combination of IP. Now each IP make a chiplet, right? So you don't, without IP, you don't have the one. Second, you have to know how to design chip, advanced node, and how know the package also. Chiplet has package issues. So purely IP company cannot do chiplet well. The purely design company, service company, it cannot because you don't own the IP, so you don't have flexibility, the knowledge how to define. So VeriSilicon, currently people ask, where's the chiplet? This is a good idea. It right reduce my effort, time, cost, but many chiplets done internally from Intel, AMD, most chiplets by their own use, for their own use. So I think probably VeriSilicon, because the characteristics of the chiplet provider, both have this strong IP and design service, advanced node, and also package. So so we're probably going to be the one provide first set of commercially available chiplet. We're well positioned for that. Like you say, if I invest, even I have lots of money, right? Investment, then you have to change. So we need to be very careful before we start to define the chiplet, right? That's why my view is that we should have a custom alliance. Yeah.
One last question that I had. You mentioned the importance of conventional substrates for multi-die modules in China.
Yeah.
Is it going to be possible to do chiplets that will work on both an interposer and a conventional substrate from a single design? Or will it require two different chiplets with different PHY layers? Or even two different interface organizations with different widths and clock speeds?
Yeah, interposer is very good, like Clovers, right? All those things from TSM is a great invention and made big influence for high-end computing. But the thing is, right now, Clovers, as you know, there's certain shortage, not getting better, right? And also quite expensive. In theory, in 12-inch wafers wrong, you cut a big chip out on the side, or waste. The bigger the chip, the waste is, right? And also other things. But recently, I think there's something called the panel level package. We want square. We want 4 times bigger as 12 inches. In that case, but this substrate had to be flat. Okay. Then you took the die from the wafer, put on this one. Then you do interconnect on top. Chip first, interconnect. In this large scale, no, you cannot think simpler than that, right? So this is without complicating this, you need interconnection, but they had to be very flat. The whole piece at the packaging panel. So people had this idea, tried to do this many years, all the leading fab guys. But this time, this company called Silicon Box actually did well, solved this. Initially, results showed very high yields. So this potential can increase the volume and also reduce the cost. Okay, I think not only Silicon Box, later on there's some other company maybe can offer, including China companies, working on this line. I think this is very important, not only for chiplet, it's critical for chiplet actually. If you don't have a supply and the cost too high, that's also a problem. The idea separate is good. Once you put together very expensive or don't have capacity, that will be the bottleneck. So we closely work with Silicon Box, and although we do covers also for our packing for our customer, but I think that interposer is not the only way, but we try to make the chip can work with both, right? So this is good new direction. I think you should pay attention, called panel level package. I think critical packaging issue for the commercialization and the launch of chiplet.
This has been fascinating. Are there any other specific areas we should be watching to understand where China in particular is going with this?
Yeah, I think the chiplet, not only for automotive is one thing. I think a few years ago, we did a chiplet for laptop for Google Chromebook. As you know, right now, M1, M2, M3, right, do extremely well. Used to they use other people's CPU now very well. Chip getting bigger, they put it to extreme. The best process, the biggest chip, one point is M2 Ultra still is two pieces. Even you do drive to extreme cannot win, right? Why so big? Because SRAMs. If you look at the whole chip SRAM, right? You need a large cache, right? For the performance. So a few years ago, we did it for Chromebook. That time, actually 12 nano, all the processes, 12 nanometer one die. Many of IP from VeriSilion. Like I said, we have besides CPU, right? And also we put the custom DRAM in the first level. We call final level cache for the 4 DRAM piece into one package. Now that's really a good way to do. I believe this segment, besides the car, the autonomous driving, I think right now people talk about AI PC, AI phone, right? People don't have much incentive to change the phone, change the laptop. Then we have problem with consumer electronics. So the camera is good enough right now, right? Take pictures. So you want people to change phone, I think you need to say this AI phone, right? See, you can tell there's lots of features like Samsung one, right? You want them to change PC, probably AI PC. Right? Then you need lots of memories, lots of computing because you have different, because people think we do training on the cloud. Actually, you need the fine tuning at the edge, right? Inference at the edge. So 3-step, not 2-step. And number of chips at the edge for fine tuning and the inference should be much more than number of chips on the cloud for training. So fine tuning is kind of training. We talk about general model, but we talk about vertical segment general model for medical, for other things, right? For financial, for example. So I think this is the one at the edge, the AI PC for them, right? Even though the AI phone, so the chiplet is the way to reduce the cost, to increase the performance. So that's the chiplet. At least we had the experience. We did a very successful, first silicon success. We're putting to the laptop. I'm talking about main chiplet only 12 nanometer that time, right? So I think in summary, there's 3 segments going to first launch chiplet. One, autonomous driving, right? Another is this, I thought this AI PC, next level PC, right? The third probably data center, even in the edge, right? We need lots of chips for the data center for training. I think it's not necessary to do a bigger chip. Cost not effective, performance not necessarily the best. So those 3 areas will be the first to take off the chiplet. I hope in the next couple of years this will happen.
You mentioned 3 areas that are all heavily dependent on SRAM. And in that past, SRAM has always been just a huge portion of the monolithic single die.
Yes.
Is this going to mean that we're going to start seeing SRAM chiplets that are, the process is tuned for SRAM and the die is either just SRAM or it's a cache?
The cache not necessarily SRAM. For example, NAND getting better performance, right? Right. And it's cheap also. So given the advance of NAND, right? So I think the cache, we need to rethink the cache structures. We call final level cache, right? So therefore, you don't need to depend on everything on chip. But DRAM, integrate DRAM is quite difficult, right? Only way to increase the cache, to put a lot of SRAM. That's why chips are getting bigger. But not necessarily make SRAM cheaper. You rather customize the DRAMs as part of the cache, because the size is bigger. Because you look at the local training, you need lots of memories, right? Customized DRAM means that the IOs, the certain thing, because chiplet, inside chiplet, your distance so short. It's not off-chip kind of things. Your IO is half IO. The IO can be much, right? Can be array IO, for example, right? IO can from middle. Look at you cannot each low, each can't take out something, right? You can memory design for such things. You can change the structure because physical changes so close. The penalty of chip is so low, and it can be array form. You can come from middle rather than the edge. So consider that's why, like I say, the system in packaging, at that time I said they should be the giant chip rather than miniaturized PC board. The characteristic is totally different from the off-chip kind of penalty on the board, right? So I think this change, this cache structures is not necessary for the SRAM chiplet, in the DRAM chiplet. Yeah.
Junko, I think you said you had some follow-up questions.
Yes. Hi, Wayne. This has been really fascinating because you mentioned a couple of things that did not really, I hadn't really considered, that you were talking about customer-defined chiplet specifications, especially for
the chiplet, especially hard, yeah, because chiplet is once you define, you cannot change.
yeah.
I always say, oh, this one you need to fine tune, that's okay. Chiplet, if I take about chiplet 5 nanometer, very expensive. If some guy tell me too much, the other guy say too little, then I'm in trouble, right? So therefore, only way is, first of all, is domain specific.
Yeah.
This is only for one domain. Of course, you need to be bigger domain, not only for one customer, right? Yeah. But also you need early adopter align with customer. They pay, they must think it seriously. If I got 5 guys, at least they have 5 customers, then I was why to do this chiplet.
So this would be somewhat, but this would be something different from, for example, IMEC is working on sort of automotive focused chiplet specifications, but what you're talking about is actually more commercial, meeting more commercial needs of the Chinese automotive companies, correct?
Yeah, not Chinese. I'm talking about the one show me this chiplet definition not for China. It's from big European top car company. Okay. I said, well, this is your secret. How to partition, right? This is really the secret. Years experience, the system level partition. Yes, they say, if I don't open, I have to do everything myself. Big investment, right? I have to open. Therefore, this become probably soon they're going to open this definition standards, let other people to take the chiplet. So they want each chiplet have few people responsible. So if someone will screw up, they can change or have some competitions, reduce costs, other things. I think this is the right way to do it. Then they focus on software on the top. That's a smart thing to do. Yeah. Right? The key, they still can make a difference, the software, whatever, on top. So they don't mind this chiplet partition open to the public, other car company can do it. Just for one car company, look at the model right now. Not 5, 6 years. Maybe a year or two, they change the model. Right, it's difficult to revision your SOCs for even for one companies, and right now we are doing the one of the China company is actually the chip probably is more advanced than Orin. The current order is Orin NVIDIA, right? More advanced the next generation, but that's probably the last time. Why? If it's failed, is the last time. If it succeed, also last time. Why? Because you cannot doing chip SoC for cars like doing SoC for cell phone. The scale is different. If you look at each car, how many cars you can sell, right?
Right.
Right now they invest chip for car like invest right for the cell phone. NVIDIA is different; they're more broad, right? It's not just for car. So I think that this is the not sustainable. Doing one, especially one car company for their own cars. That's they invest too huge and not flexible. Actually, they evolve quite well, right? You cannot redesign the whole chip. Right, but you change a couple of chiplets, that's probably fine. But then, like I say, you need to open not for one company. You need I'm glad that company, the biggest European car company, think about that way, right? Open standard, open the partition, then for all the chiplet companies to participate, right?
Okay, thanks. All right, back to you, Ron.
Yeah, I think that wraps it up in terms of the time we have and the questions that we had. As Junko said, this has been absolutely fascinating. I think it's been a wonderful window into the practicalities of the chiplet movement and some specifics about the Chinese market as well. Again, This has been Wayne Dai, the founder and CEO of VeriSilion. This is the Ojo-Yoshida Report's webinar series, Dig Deeper on Chiplets. And this is Ron Wilson saying thank you very much.
Thanks.
Thank you, Ron. Thank you, John.
Right. Bye.
Yeah, bye-bye.
Chiplet-based multi-die systems are taking the industry by storm. Are you ready for new and unfamiliar challenges around die-to-die connectivity, chiplet integration, and system reliability? Synopsys, backed by its broad experience, close ecosystem collaborations, and comprehensive IP and EDA solution, offers help for fast chiplet-based multi-die system development. Visit synopsys.com/multi-die.